let us look at transformations of functions. If you know what the basic function looks like and it gets transformated, you should be able to graph it. It's just moving left, right, up, down, eventually upside down. You should know that y equals x squared goes this way. So let us consider f of x equals x squared. Let's consider f of x equals x minus 2 squared. And let us also consider f of x equaling x plus 3 squared. Now, if you square the same number, you get the same answer. I don't care how you came to squaring a particular number. 4 plus 1 is 5. You square it, you get 25. 10 divided by 2 is 5. You square it, you get 25. 7 minus 2 is 5. You square it, you get 25. Doesn't matter how you came to get to 5. If you square it, you're going to get 25. So let's make up a table for some points, and let's see what's happening. Let us try to get the same y values. For example, if I plug in 0 for x and I square it, I get 0. Well, what should x be? So I'll be squaring 0. Now, everyone should know that 2 minus 2 is 0. If x is 2, 2 minus 2 is 0, and when I square it, I get 0. What should I square to get this to be 0? So I'll be squaring 0. Excuse me. What should x be? So I'll be squaring 0. Negative 3. If x plus 3 is to be 0, because I want to square 0, then x is negative 3. Negative 3 plus 3 is 0. Square it, get 0. The same y value. Same y values. We got 0 in all three cases. Now let's square 4. Let's square 4. Well, if I want to square 4, I should let x be 4 in the first case. 4 squared, 16. If I want to square 4, I should plug 6 in. Because 6 minus 2 is 4. And when I square it, I get 16. If I want to square 4 in the last case, some number, x plus 3 is 4, 1. I'll be squaring 4 then. If x is 1, I'll be squaring 4. What if I want to square negative 5? Well, first case, I should let x be negative 5. And when I square it, get 25. If I want x minus 2 to be negative 5, negative 3. If you're already at negative 3 and you take away 2 more, you'll be at negative 5. X should be negative 3. Negative 3 minus 2, x is negative 3. Minus 2 is negative 5. Square it, 25. I'm adding, in the last case, I'm adding 3. I have some number, I add 3. 1, 2, 3. And like magic, I get negative 5. And after all, that's what I want. Negative 6. Oops, negative 8's the number. Negative 8 plus 3 is negative 5. So I let x be negative 8. I add 3, I get negative 5. I square it, I get 25. Okay, let her see what is going on. These are called horizontal shifts. Okay, in the first case, here is y equals x squared. Y equals x squared. In the second case, it's y equals x minus 2 squared. Remember, another name for f of x is y. So y equals x minus 2 squared. Well, you know what? We got the same y values. How interesting. Oh, the x values are different. Oh, 2 more. 6 is 2 more than 4. Negative 3 is 2 more. The x, to get the same y value, the x's should be 2 more. That is, to get this y value, x needs to be 2 more. To get this y value right there, I need to move over 2. To get this y value, I need to move over 2. Every point moves to the right 2 places. Every point. And then what we end up with is a graph that looks like that. This here is y equals x minus 2 squared. When it's minus 2, we move to the right 2. Let's look at the last graph. Oh, what do you know? The same y value, 0, 16, 25. What can you tell me about the x values from x squared and the x values of the function in question, namely x plus 2 cubed? Well, 0 to negative 3, it went down 3, 3 less. 4 minus 1, 4 minus 3 is 1. Negative 5 minus 3 is negative 8. That is, to get the same y values, the x's need to be 3 less. So we live up to that. This point, I go 3 to the left. This point goes 3 to the left. This point, 3 to the left. 3 to the left. This point, 3 to the left. Every point goes 3 to the left. And what you get is a function that looks like that. Okay, how do you know to go to the left or right? The easiest way I can think of is take what's being squared. It's called the argument x plus 3. Set it equal to 0. Solve that equation. X equals negative 3. Negative means to the left. Goes 3 to the left. In the center one, take x minus 2, set it equal to 0. X is 2. Positive 2. Go 2 to the right. The blue graph went 2 to the right. Okay, this is what horizontal shifts do. They move the graph left and right. They just move the graph left and right. Okay, let's look at vertical shifts. Suppose you have f of x equals x squared, f of x equals x squared plus 3, and f of x equals x squared minus 2. Suppose you have these 3 graphs. And in these graphs, we're going to keep the same x value. We're going to use the same exact x values. We're going to use 0, 2, and negative 4. 0, 2, negative 4. 0, 2, negative 4. Well, you square 0, 2, and negative 4, you get those numbers. But that's exactly what I need to do here. But then I add 3. I take 0, I add 3. I take 4, that is, I take 2 squared, 4, I add 3. I take negative 4 squared, which is 16. So I did x squared, and now I add 3. There's going to be 3 more. Over here, we have to square. You get 0 squared, 2 squared, negative 4 squared. Then you take away 2. and you get negative 2, you get 2, and you get 14. It is the y values change. They go up and they go down. Here is y equals x squared. Y equals x squared plus 3. Every point goes up 3. 1, 2, 3. Think of that. That's the lengths we're going up. Every point should go up exactly that amount. Every point should go straight up that amount. Here is y equal x squared plus 3. Here is y equal x squared. Now, what about x squared minus 2? Every point goes down 2. Let that be distance 2. Every point goes down that amount. Every point goes down that amount. Here is y equal x squared minus 2. If I could abuse the word parallel, these three curves are parallel. They're always the same distance apart. This abused way of saying parallel is that these two curves that I just drew are always the same distance apart. If you took a ruler and measured this distance, it'll be the same as this, and this, and this, and this, and this, and this. They're always the same distance apart. Of course, parallel lines are supposed to be straight. So that's the theory behind it. Now, what you need to know is how to graph the basic functions. You need to know that to draw x squared, you go to the center, and you go like this and like that. That's y equals x squared. To draw x cubed, you go to the origin, and you go like this, and you go like that. Learn how to do it the way I'm saying. Do it the way I'm saying. You won't have trouble. It's no big deal going to the origin and doing this. This is y equals x cubed. This square root of x, you go to the origin, and you go like that. That's the square root of x. The absolute value of x. You go to the origin, you go like that, you go like that. Those are straight lines. This is the absolute value of x. 1 over x. Here's the origin. It goes like this. And it goes like that. Gets closer and closer to the x and the y axis. Y and x. This is y is equal to 1 over x. 1 over x squared goes like this. Again, it's centered about that origin. Y equals 1 over x squared. You must know these 6 graphs. Okay? You need to know these 6 basic graphs. If you know these 6 basic graphs, then what I'm about to show will be pretty simple. It'll be basic. So, if you were asked to graph y is equal to x minus 2 plus x minus 2 squared plus 4. if you were asked to do that, or if you ignore the shifts, if you ignore the horizontal shift and you ignore the vertical shift, is y equal x squared. This is going to be a y equal x squared graph. But it has a shift. Now, what's really shifting is not the graph, but the axes. Just ask yourself two questions. What makes this 0, which is 2, and what does that say? And that question couldn't be any easier. What does that say? It says 4. If you go to 2, 4, 1, 2, 1, 2, 3, 4, and you think of this as the new origin, that is, think of this as your y-axis, think of this as your x-axis, and think about this just being an x squared graph. Oh, x squared, boom, boom, done. Done. I mean, it would be nice to know what that point is. When I look straight down to the x-axis, I see good old 0 there. When x is 0, copying the top line, y is equal to x minus 2 squared plus 4, which is negative 2 squared plus 4, which is 4 plus 4, which is 8. Okay, it crosses at 8. But other than finding the y-axis, the y-intercept, we were done. Just find a new origin and draw a typical x squared graph. Okay, if you were asked to graph y is equal to the absolute value of x plus 3 minus 2. Well, you want to find what's called a vertex, a new origin. What makes that 0? Negative 3. What does that say? Negative 2. Okay, so I go to this point. I go to negative 3, negative 2. Right here. I make believe that my axes are right there. So basically, I want to draw my V shape. I want to draw my V. But the question is, do I cross the y-axis when it's negative? Do I cross when it's 0? Do I cross when it's positive? Well, any time you cross the y-axis, x is 0. If x is 0, y is equal to x plus 3, absolute value minus 2. The absolute value is 3 minus 2. Absolute value of 3 is 3, minus 2 is 1. Okay, so now I know I cross at 1. Boom, boom. There it is. And you should label your axes, x and y. Now if you want to find the x-intercepts, you let y equal 0. If y is 0, then you have the absolute value of x plus 3 minus 2 is 0. So then this must be 2. 2 minus 2 is 0. The absolute value of x plus 3 is 2. So what number can I put in the bars to get 2? The answer is positive 2 or negative 2. What did I put in between the bars? X plus 3. So either x plus 3 is equal to 2 or x plus 3 is negative 2. If I take away 3 from both sides, I get negative 1. If I take away 3 from both sides, I get negative 5. That is, I cross the y-axis, the x-axis, at -1, as well as -5. You might want to find that information first. That way you can draw the lines better. If I know that I'm crossing here and here, and I'm starting here, how can I get that wrong? Other than finding the x and the y intercepts, you're just moving the axes, but you're drawing the same graph. Sometimes they make it wider looking, sometimes they make it more narrow looking. If you are asked to graph y is equal to 7 times x minus 1 cubed plus 4, the 7 doesn't really come into play too much. To find the vertex, ask yourself what makes that 0. Say 1. 1 minus 1 is 0. And then ask yourself what that says, 4. Okay? So I go to 1, 4. 1, 1, 2, 3, 4. I come right here. I make believe this is my origin. And if I put it over here for a moment, I'm getting ready to do something like that. Or is it wider? Or is it a very narrow one? The intercepts will tell me that. If x is 0, y is equal to 7 times 0 minus 1 cubed plus 4. 0 minus 1 is minus 1. Minus 1 cubed is minus 1. 7 times minus 1 is minus 7 plus 4 is -3. The y-intercept is at -3. Oops. Okay, so I'm going to cross the y-axis right here at -3. Where do I cross the x-axis? Well, y is 0. 0 is 7 times x minus 1 cubed plus 4. Bring the 4 to the other side as -4. You get -4 is 7 times x minus 1 cubed. Divide by 7. You'll find out what x minus 1 cubed is. Take the cube root of both sides. So you get the cube root of -4 over 7 is just x minus 1. Add 1 to both sides. This will become the left side. And the right side will just be x. Okay, that is, you're only crossing one time. So I go down like this, and I try to draw symmetrically up. And this x value is exactly 1 plus the cube root of -4/7. Okay. Like I said, you find their new origin and you draw something like that. It might be a wider one. It might go like that. It might be a very narrow one. It might go like that. Finding the intercepts will tell you. But nonetheless, we pretty much just went like this and like that. Whether I do it wider or narrower, that's no big difference. I ask you to draw y is equal to 3 over x minus 2. let's just change it a little bit. This 3 wouldn't matter, but I'm going to put 1 plus 2. Okay. Again, if I ignore the vertical shaft, I mean to say the horizontal shaft, and now the vertical shaft, I just get y equal 1 over x. And we know how to draw that. It goes like this and it goes like that. Question is, what's the vertex? Well, what makes this 0? 2. What does that say? 2. So I go to 2, 2. 1, 2, 1, 2. I go right here. Here is my new origin. Now, do I draw it like this? Or does it come down further? Or does it go more quickly? Let's find out where. Now, this portion isn't going to hit the x or the y-axis, but the other one will. It will hit the x-axis somewhere, and it'll hit the y-axis somewhere. But nonetheless, they need to look the same. In other words, if it turns out that the bottom one looks like this, you shouldn't draw the top one like that. You should draw it more similar, something maybe like that. Should be somewhat similar. Okay, so let's find the y-intercept. That means x is 0. So y is equal to 1 over 0 minus 2 plus 2. 0 minus 2 is negative 2 plus 2. That's negative a half plus 2, which is 1.5. Okay? It crosses the y-axis at 1.5. Here's 1, here's 2, here's 1.5. Let us now find the x-intercept. That means the other letter, y, is 0. So you have 1 over x minus 2 plus 2 is 0. Bring the 2 over. 1 over x minus 2 is negative 2, which is the same as negative 2 over 1. Take reciprocals. The reciprocal of that is x minus 2. The reciprocal of negative 2 is negative a half. Add 2 to both sides. And you also get 1.5. It crosses at 1.5. Crosses right here. So there's your graph. There it is. I drew the same graph as I really drew at the very beginning of this topic. One of the basic graphs. But we're pretending that this here is the axes. But whatever you do, label the original ones. Don't label the new axes as x and y. Okay. If you do it the way I'm showing you, no matter what, you're going to have to find the x and y axis. X and y intercepts. But I'm getting you to just do it with one more point. Whatever you do, don't plot 15 or 20 points or 8 points. You can do it with 2 points. Alright, so now just play this little game. Suppose you have this. Here's the x and y axes, and I'll give you a grid as if it was graph paper. suppose you have a graph that went like that. In fact, I meant to draw it in red. Suppose you have a graph that goes exactly like that. And this is the graph y is equal to f of x. And now you're being asked to graph y equals f of x plus 2. That means there's no horizontal shift. I didn't replace what was in the brackets with anything but x. But I am adding 2. That's a vertical shift. For example, if f of x was x squared, then this would just be x squared plus 2. We're just lifting everything 2 points. Well, it'd be nice to know some points. Well, actually, we lift every point up 2. So the bottom left point, it goes up 1, it goes up 2. It's now here. This point goes up 2. It's now here. There's a straight line. In fact, even this point right here went up 2. This point went up 2. Every point went up 2. And then, original function just goes left and right. So I go left and right, just 2 higher. Just 2 higher. And then I pause for 1 moment. Okay. And then I notice from this point right here, I go up 2 and 1 over. I went up 2 and then 1 over. So I need to do the same at this point. I go up 2 and 1 over. That is, I go here. Up. Easier way. Why am I making this harder than it needs to be? This point right here goes up 2. That is, it goes here. There it is. That's the new graph. Let's finish it up in red. That's the new graph. It went up 2. Here is the graph f of x plus 2. Okay, what if I now want to graph y is equal to f of x minus 2? Okay, what makes this 0 is 2. That is, I just go 2 to the right. I go to the original graph and I move every point to the right 2 places. I move every point to the right 2 places. Excuse me. Move every point to the right 2 places. Alright, every point is moved to the right 2 places. So let's do that. The bottom left point goes here. This point goes there. This point goes here. Notice I just deal with the end points, the corner points. This point right here goes there. So the new graph, I'll draw it like this. Only because this is duplication right here. There it is. There it is. I go up 2, I go to the right 2. This one tells me to bring up every point 2. Well, if you have this point and you have a straight line between them, if you bring up every point 2, shouldn't you still have a straight line? Well, if you have these 2 points, there's your straight line. I mean, you can bring up this one, but it's going to be there, and this point is going to end up there. And for the record, if you have this point, and it goes like that, say, some kind of curve, well, if you bring every point up 2, you're going to get the same exact curve. It's just 2 higher. That is, this distance is 2, and that's 2. Every point went up 2. So what the graph looks like will not change. What will change is where it's located. It's now located 2 higher, or 2 to the right. Okay, we'll do some more of these later. It's a big topic.